Good morning, everyone. Thank you, Konstantine. It is my pleasure to be here. Let me first introduce myself. I'm Adonios Chatzipavlis. I'm a data solution consultant and trainer, and I have been in the information technology industry since 1988. I have been an MCT since 2000 and Microsoft Data Platform MVP since 2010. Generally, I started my career as a programmer. I don't like to say developer. And I started using SQL Server since version 6. This means I have a lot of experience with this product, more than 25 years. Also, I have more than 60 of certification, mostly in Microsoft products. And I'm the founder of SQLschool.gr. SQLschool.gr is a community for professionals who use the Microsoft Data Platform. And in this community, you will find articles, webinars, videos, resources about Microsoft Data Platform. You can join us or follow us in social media to keep up with our community. And today, in my session, I would like to speak for a feature of Azure Synapse Analytics, and this feature is lake databases. Azure Synapse enables us to combine the flexibility of storage in a data lake with a structured schema and SQL querying capabilities of relational database through the ability to create a lake database. So what is a lake database? A lake database is a relational database schema defined on data lake files store that enables data store to be separated from compute used to query it. Lake database combine the benefits of structured schema that include support for data types, relationships, and other features typically found in relational database systems. With the flexibility of storing data in files that can be used independently of a relational database store. Essentially, lake database is a new way of defining data structure on data that will be hosted on data lake, and data processed with Synapse data warehouses to ultimately cater a data lakehouse solution for the desired use cases. So, we know that in Synapse we have the serverless database. So, what is lake database versus SQL Server database? At face value, they are very similar. They are both means by which you can query data in your data lake. However, lake databases are special in that they are synchronized between the Spark and the SQL serverless engines in Synapse. This functionality, and it is amazing functionality, reduces the scope of what lake databases are capable of doing. The feature set of serverless database can be thought as much more like that of a traditional Azure SQL database dedicated pool, the known SQL data warehouse. Of course, there are a number of things you can do due to the nature of SQL Server databases. We will see all of this in my demo, But I would like to say that lake databases are more constrained. Under the covers, lake databases is metadata only replicated SQL Server database containing a handful of external table objects corresponding to the data you have defined in one of above sources like data lakes. The next question is when I should use a lake database. The primary benefit of lake database is the interoperability between the different compute engines, Spark and SQL pools. For example, you don't need to duplicate tables of data if you have a created database in Spark and you want to be able to query the same data via Transact SQL in SQL Server serverless. Similarity with Synapse Link for Dataverse, you don't need to manually export the Dataverse data and manually create a new serverless database in Synapse just to be able to query the data. If you want to query the data using serverless, you can do that, and performance characteristics will be largely identical to the equivalent query in a normal SQL serverless database. If you want to query the data using Spark code, you can do this also. And of course, in this case, we are using Spark Engine. To be clear, the main scenarios where data lake are good to fit is when we want to easily query tables of data from both SQL Server Engine and Spark Engine, and if you want to utilize the, let's say, clicky draggy droppy database template using the designer that we have, you have an excellent result. So let's start with demo. As told you before, Azure Synapse Analytics enable us to combine the flexibility of file storage in data lake with a structured schema and SQL query capabilities of relational databases through the ability to create a lake database. A lake database, as told you before, is a relational database schema defined on data lake store that enables data store to be separated from the compute used to query it. To support a lake database, of course, you need to have an Azure Synapse Analytics workspace. There is no need to have a dedicated SQL pool since we can define the lake database using the built-in serverless SQL pool. Optionally, we can also use a Spark pool to work with data in the lake database. So let's start with our demo. I have got a Azure Synapse Analytics workspace, and let's start to create a lake database. Before do this, let's go to data lake. I have a data lake, and I have already export my data from my demo database, ElasGate database, in two different formats, CSV format and Parquet format. As you know, Parquet format is preferred because it's self-contained and is compressed and it has a lot of benefits. If you compare with CSV. And in each folder, I have my tables that I have in a LastGate database in the appropriate format. For example, for my customers, I have the Parquet files. If go to CSV, I have, for example, my customers in CSV format. Okay, it's very easy to do this. So let's go back to my Synapse. If I go to data, you will see that we have the linked services, the linked data, which is the Synapse, and my data lake is this container. In this container, we'll see that we have the same structure. If go to workspace, you will see that we have two options. The first option is the dedicated pools and server dedicated SQL pools and serverless database, but we have an extra feature that is the lake database. Here I have already created my LastGate database with files that is in Parquet format, but let's go from the start. First of all, if I would like to create a new database, a new lake database, go to plus sign and choose lake database. We have a GUID. In this GUID, we must put the name of our database. Also, because this database reads data from data lakes, we need a link service that points to this data lake. And of course, we need to provide a folder that in which the data, the files must belongs. This folder is not created automatically. We need to create this folder by hand. So, for example, if I would like to create this folder, I need to go to my container, and let's say that I need to create a new folder, and let's say database 1. Okay, the last option that I need to set up is the data format. The data format, if I'm going to use delimited files, CSV files, or Parquet files. In this case, let's say that I'm going to use a delimited files. If we would like to create this database, I need to put to publish it. Let's publish it, this database. And the next step is to create a table that points to these files. Let's say that I'm going to create a custom table. Yes, I have the ability to create a custom table. In this custom table, I need to provide a name. Let's say that I'm going to name the table categories. Of course, we need to provide a description if I would like to provide a description. And of course, we need to say where is the location of files for this table. By default, inherited by a database, which means that I need to create a table, a directory in my database. Let's say that I need to create a new folder, and let's say that folder is categories. Okay, let's go back here. It's a delimited file. If my CSV file has a header, we say that we have a header rows, and of course, what is the compression, what type of a delimiter we are using, and stuff like that. If we are using quote or double quote for our strings, in my case is none, I'm not using a quote. And after that, we need to put the columns, to define the columns. If I go back to my original database, because I don't remember the names of columns, let's say that I'm going to use the categories. The categories has 3 columns. The category table has 3 columns: category ID, category name, and description. Let's go back here and say that is the first column is category ID. If this column is the primary key, yes, we can define the primary key. But as you know, in Synapse, primary keys are not enforced. This means that, okay, created the primary key, but it's not like the primary key as you know in a traditional relation database. This means that if you say put a record with ID 1, you can repeat the same statement, the same statement. You will see duplicates for this row because this primary key used because it's a metadata information, and internally this used for example, for join queries and stuff like that. If you would like to say a description in this field, yes, you can put a description. And the most important thing is the data type. Data type is very crucial for this logic. Okay, let's go to put another column. The next column is, I don't remember, is category name. Let's go to say that I'm going to use the category name. Category name, it's a string. I don't remember what is the length. It's 50. Okay, 50. And after that, the last column is description. And this, if I remember correctly, 200 characters. Okay. I have one table. Let's publish it. And now, what is the next step? I'm going to my data lake. Let's go to already extracted CSV files, and let's do a download to my PC, the CSV file. Okay, you can create a pipeline to do this automatically, but I would like, for my demo purposes, I would like to explain all the steps. Already downloaded. Let's go back to this database, categories, and upload file. Okay, and let's go back to my Synapse. If I refresh my tables, you will see that I have the categories, and let's say that I would like to make just a select top .100 rows. And voila, easy peasy. Just create the table schema. Of course, the table schema must be according to data that I have in my file, CSV, Parquet, stuff like that. And now I have the ability to query the file that I have in Data Lake. Any questions? Okay. One case is to create a table from scratch, like I showed before. Let's go back to create a table from Data Lake. To do this, let's go to my already exported files from CSV. Let's get customers. Let's download it to my PC. Okay, I can move it to another folder, but using this tool, but I don't like to do this in this case. And after that, let's go back to database 1, create a new folder. Let's say that this folder is customers. And in this folder, let's upload CSV file. Excellent. Let's go back to Synapse and let's create from Data Lake. Let's say that this table is customers. And of course, I need a link service that connects to my Data Lake. And after that, let's go to this folder. Customers. Of course, I have the ability to create, to select customers CSV, but in case that I have a scenario that I have a pipeline that in intervals get data from my source system, export it in CSV or Parquet files and put it here with a timestamp and stuff like that. Or if I have a scenario with incremental updates, I don't need to be joined with a specific file. I need to be joined with a specific folder. In this case, let's say that I'm going to read all the folder and the files that I have in this folder. So in this case, we see that we have 2 stars here. That means that I'm going to read all the files. Oops, my mistake. Let's go again from Data Lake. Let's say customers. Let's select this one and continue. It's a comma delimited. My file contains, the first line is column headers, blah, blah, blah. Okay, let's create it. You will see that now that I have all the customer with definition of the columns. If I go here, and the only thing that I need to do is to say the primary keys, probably the descriptions, and of course the data types. For example, here say it long, but I know that my data type is integer. I can change this to integer. Of course, I have the ability to change all the strings to the appropriate size. I don't need to have 8,000 characters. In this case, I need to change all of this, but I'm not doing this because I need to save time. If I go here for my customers table, you will see that I have company names 40 characters, 30, stuff like that. Okay, okay. I'm not going to do this. Let's publish it. If I go here and do and refresh, you will see that I have a customer table. Let's create a query. Okay. I don't see my mistake right now, but no worries. We have the ability to create this one with the demo that I saw before. Let me think about it. I'm going to proceed, and I go back here to see what happened. The third option to create a table is to choose from template. Here we have some data models from different areas. Let's say that I'm going to use banking. If I click continue, you will see that I have a bunch of tables here. With some data. For example, let's say that I need to use accounting and financial reporting, and let's select the currency table. I would imagine that you would like to create a currency table. If I choose to create the currency table has a lot of fields. In columns, you will see that we have ISO currency code, currency name, country, symbol. You can keep all the fields if you would like to have all the fields, but we have the ability to remove some of these fields. Let's say that we don't like to have currency symbol, for example, and after that you just say add, and we have the tables. What you need as a next step is to have a file in your data lake according to the structure of this table. This is the way to create a lake database. Let's go to my Elasgate Parquet database. That is a database that I have already created to sort to make my demo short. And in this database, I have a lot of tables, all the tables that I have in Elasgate database. First of all, let's go to see the design of this database. If you see the design of this database, you will see that I have the products table, the suppliers table, subcategories tables, categories tables, and stuff like that. Also, notice that I have the ability to create relationships between tables. If you would like to create relations between tables, it's very easy to do this. For example, let's go to products table. You will see that I have a relation option or relationships options, and here I have the relations that I have already created between products and other tables. If you go to add new relationships, we see two options. The first option is from this table to another table, and the other option is from another table to this table. This means that if, for example, I would like to create a relation between products table and order items, I'm going to use products table. If I have a different scenario, I'm going to use two table. And in this case, I'm using the relation and say I'm going to, for example, from table, the table is products. I pick the field. in which table I'm going to, I would like to create these relations, and of course the, the column. And now I have got a schema, a metadata schema of all of my files that I have in a Lake database. What is the benefit of this? The benefit of this is, for example, let's say that I would like to create a query. This query, as you know, reads this specific table that points to the specific directory. But let's say that I would like to say, let's keep it top 100. And let's say that I would like to say as O inner command. Inner join just a moment too. Customers as C on O dot custom cast ID and let's say that I would like to read order ID, order date, and let's say that I would like to say company name. If I run this query, okay, my mistake, no worries. If I create this query, you will see that I have the order ID 1, this order is in this date, and the customer name is the name that is in Greek, Yanukaki Ike. Of course, we have the ability to create join aggregated queries and stuff like that. This gives me the ability to see the data in a most efficient, easiest way in our data, which exists in SQL in a data lake, and I have the ability to make some transformations. And after that, because the next step is to get this data and put this data to dedicated SQL pool, I have the ability to put to create a pipeline, to create the data flow that reads this data and put this data to dedicated pool. Before before explain this, let's go to another way. If we would like to update this data, which is in a data lake, with new data, or reads every day, reads data from my data source, and I would like to do updates and stuff like that. In this case, I need to have a Spark, pool. Let's say this one. Imagine that I would like to insert the new rows that I found from my data source to this table in this lake database. Let's say that I would like to create a new record in my Spark, in my Lake database using Spark, and let's say that I'm going to put the record with this ID. My Spark is timeouted. Let's start it again. It takes some time to bring Spark in live, come on. This happened because my Spark is in a suspend mode, so no worries about that in a production system. Okay, now started. And finished. If I query for this record, you will see that I have the record in my database. And of course, let's grab this query and go not here, here. And let's query. Be careful the notation of definition of this table in a Spark. Let's run it. And voila, in our table we have the new record. What is happened behind the scenes, if for example go back to my LSK database in Parquet and go to customers, you will see that I have another Parquet file that with a strange name, but it's not a strange name, it's a GUID with which contains this entry. I have already run before with another record, so this is the previous record, and this is the new record. The new record is here with this timestamp. Okay, if I would like to move this data to dedicated SQL pool, we know that if we'd like to do this, we are able to get data from data lake to dedicated SQL pool. We have the ability to use serverless queries, either with open row set or using external data tables. But in case that we'd like to get the data that we have in the lake database schema, let's say that I would like to do this. I'm creating a new pipeline. In this pipeline, I'm using a data flow. This is the only way to do this. And in the data flow, I'm creating a new data flow, but when I choose a new source, I'm not going to use integration dataset or inline. I need to use a workspace database. If I choose workspace database, you will see that I'm able to use any of my lake databases. And if I would like to use, for example, customer tables or categories tables, stuff like that, I get the data that I have in a data lake via the lake database, and after that I'm going all the transformation that I would like to do. questions? Any questions? Okay. I don't have any other things to say. I would like to thank you for your presentation, for your participation in this session. Enjoy the rest of Summit. Thank you very much, and bye-bye.